Hey guys, this is Mainak, your Civil Pro. So today I have come up with one single lecture on STAAD Pro Connect Series and RCDC. So we are going to take a building, all the details, downloadable materials you can find in the description, download that for practice. Okay. And we're going to take this particular plan of this G+1 building, and we're going to do the entire, design in STAAD Connect Series. And because there are some, difference between the STAAD Connect Series and the Select Series. So Connect Series is the latest version. So already I have given a video on how to download that. And so if you just want to learn this Connect Series steps, the whole steps, and then the detailing of all the members, beam, column, and footing in RCDC. So we'll do that. Okay. So just let's, whenever you watch the video, make sure you have some time, and this video might be a little bit long, but if you just pause and then watch all the steps along with me and practice it, definitely you will be able to confidently design a building model in STAAD Pro Connect Series as well. So that's the plan. So let's move forward. So first of all, this is the plan here. I'm going to mark the coordinates here because we can also import the this center line diagram, that is also a way. But this time I will just use the your particular coordinate system. Okay. So I'm going to start from 0 here. This text, multi-line text I'm taking, and I'll just mark it here. This one will be 0, comma 0. This is my coordinate. So you can see the difference in the text, this style. So I'll just take this one, MA, enter, and then I'll just do this. So this will be my default text setting, right? And now I'll just copy this to the next level. So here you can see everything is done, and I'll also need the memory calculator to calculate the other coordinates, right? So this will be 3725 comma 0, and then the next coordinate. Let's do the next coordinate. This will be 3725 plus 3055. So 3725 plus 3055 equals to 6780. 6780, comma 0. And this one will be this will be 6780 plus 3150, 9930, right? 9930. This will be 9930, 0. So this is the thing, and the x coordinate for the next row set of rows will remain the same. So we'll copy this and do it here, and this will be only the y coordinate we need to change, 3978, right? So 3978, and here also every y coordinate 3978. So just you can also just select this and copy, and after that you can just simply paste it here, right? So select Ctrl plus V. You can just change the alignment a little bit later, or even change the text size as well. Consider that. Ctrl plus V, and here also Ctrl plus V. So this is done. Okay, there's multiple brackets. I have, during copying, I have done. So no problem in that. I'll just go ahead and delete these things. So this is done, and then now I'll copy. So this is stuck. This coordinate is also the same. Okay, this coordinate also will need, actually, because there is no column, but there is an intersection, so we need the this coordinate. So only the y coordinate will change. So it is 3978. So it will be 3978 plus 2200. and it will be 6178. So it will be 6178. So we'll just do here 6178, and here also we'll do 6178, and then this also, or next coordinate is the same, and this is 6178, and this is done. So copy this for the next two levels. Here might change the arrangement a little bit so that it makes space. Okay, now for the last one, we need this x coordinate as usual remains the same, only the y coordinate will differ. Let me just for the ease of pasting, turn off OSnap, and then I can just put it anywhere and then turn OSnap back on. Right. So here just the y coordinates will be changed. Y coordinate is, as you can see, it is 3978 plus 4472. So it is actually 3978 plus 4472, and it is 8450. So simply we can just double click and write here 8450, and we can copy this and just paste it here also along with this. So this is the done, and now for these two also, next two actually, can copy this, and only the y coordinate will change here. So the y coordinate will be, again calculate the y coordinate. So y coordinate will be actually 3978 plus 2200, which was 6178 earlier, plus uh, 3124, enter 9302. So here just will write 9302, 9302. Here also we'll write 9302. So this is the case here, and this is the case, and after that the last of the coordinate systems will just copy all the column locations from the bottommost part, select, and after that copy and do it here. So the total I can just see by adding. So it was 9302, and plus 9302 plus it will be 3148, 1240. So 1240 will be the coordinate here, and you can just 1240, and you can just copy this, Ctrl plus C, and paste it in all the other parts. Paste it here, and paste it here, and also paste it here. So So these are the coordinates here, and these coordinates are done. And once these coordinates are done, we can just open the STAAD Pro and import the STAAD file, uh, write it the coordinates one by one, or else there is a better way to do it. In my point of view, if you just use MS Excel, then it's way better. So I'll just open a new spreadsheet, right? Uh, a new spreadsheet. I'll just open it using OpenOffice, by the way. It's similar to MS Excel, but free. And okay, so just do this, and AutoCAD also. Maybe I'll just take AutoCAD to the right side, and yeah, now I can write all the coordinates. So if you see STAAD Pro, so it will be node number, node, and then it will be these are the coordinates x, y, and z or z. So you have this x, y, and z. So in AutoCAD and STAAD Pro, y and z are interchangeable. So y will be 0 for all these. This is the plinth level, so it will be 0 for all. And x and z coordinates will enter using this diagram in meters, right? So one node, first node, x coordinate is 0, y coordinate is 0, z coordinate is also 0, right? So all 0 here. Second one, it is it will do it in meters because STAAD Pro does in meters, 3.725, right? And okay, 3.725, and then 0, and then we have this 0. So Z potential is 0 for all. So 6.780, 0, and also 0. Next is 9.93, 9.93, 0, and 0. And then next is your X is 0, right? X will be 0. Z is, Y is always 0. Z is, let me just copy this, and this will be 0 for all. So just to do some extra. Okay. Now Z coordinate will be 3.978, 3.978. And then next is 3.725. And next is your, okay, I missed one. It is actually this one. So let me just copy and do it here. So it is, next one is your 6.78, and then it is, we can just add decimal place here. Okay. Okay. So that's it done. So 6.78, and after that 9.93. So this 9.93, and 3.98 this, and decimal plate. Okay. 3.978, this is a constant for all these things. So now this row is over. Now we move to the next row. The next row we have three, uh, you know, 3 points or 3 nodes. So first of all is 0, and the second is 3.725, and the third one is 6.78, 6.78, and the y coordinate, oh sorry, z coordinate is 6.178, 6.178. It is the z coordinate. So we'll just control plus C, control plus B, control plus B, 3. So in the next row, we also have 3. Okay, I think there is a mistake here. This will be 8.450, right? It will be 8450. Okay, so we have 3 here. So let's enter here. So it is 3.725. Then next one is 6.78. Then the next one is 9.93. And then the y coordinate is 8.45. the Z coordinate 8.45, and it will remain the same for all the three. Then the next coordinate, next row we have two. So one is 0 and another one is 3.725. And for both of them, the Y coordinate is 9.302. Here also, just do 9.302, and this is done. And in the next row, we have four coordinates. So it will be 0, and then 3.725, and then 6.78, and then we have 9.93. So don't forget to copy zeros and paste it here. And then the Y coordinate, definitely 1.24. Just copy, paste. So these are the coordinates. Now nodes can just have, we have 20 number of nodes here in total. So once we have these nodes, we can just, first of all, let just minimize the CAD file, and we'll open the STAAD Connect Series. I'll also give you the link of the download STAAD Connect Series. We can also watch the video. So this is the STAAD Connect Series, and I'll just open it. Take some time to open. So once it opens, just close this pop-up, which comes up every time. So this will come up, and after that, you will just, once this comes up, so just click on new, and you have to give the folder location which you want to save the file. So let me go to desktop, and here we'll just have this file. So stat file. Okay, select. Okay, no, this is the folder name. Sorry, my bad. So folder is already selected. Just select the folder. So, and here you can name the file. So stat, just name it stat file PDF. So English in matrix, metric in as far as Indian part is concerned, we mostly go with metric, kilonewton, Newton, and these things. So metric, and then just click on create. And when this is created, you can see the X, Y, Z coordinates come straight up. So we just need to copy it from the Excel and for the spreadsheet, and then paste it. So we'll copy from the nodes here, and Ctrl plus C. This is actually copied. And once this is copied, we'll just select this one here, and then Ctrl plus V, and then click on this. So the nodes will come up. And when the nodes come up, you can just select the view from the top view like this. And you can also see from the top view like this. So you can see there is some error, which it seems there is some sort of error here in the coordinate marking. So we have to kind of rectify that. Okay. So first of all, you have to identify the error which is there, and we have to rectify it. Okay. So let's check the coordinate first, right, in the Excel file. So we have identified the problem. Only first of all, you need to go to view, and then this is the top view. Okay, from the top you are seeing this. So the problem was in these coordinates. This is not 1.24. This was not 1.4. This was actually 12.4, 12.45, right? So you can see from the CAD file also, and you can just have a just maximize this for a moment, and have the from here to here in total. You see, this is 12.45, right? So this will be 12.45. All the coordinates, you can just simply change it. 12.45, and this also 12.45, and then the next two also 12.45, 12.45, and here 12.45. So now it is fixed. So you can see I can match from the AutoCAD file, and also from the STAAD file, that the arrangement looks similar. So we are good to go. And once this is done, just click on Ctrl plus S. It will be saved till now. Okay. So now what we are going to do, we are going to go to geometry, add beam, and just add the beams. Go from left to right. Not that it is some rule to go left to right, but if you have an order, that then that's better. So we're going like this, left to right and bottom to top. So now you can see this, there is a I want to add a node here, or I have a chance not to add a node here. So I have to decide actually. So I can add the beam here, or I add the beam there. Okay. So I'll decide to add the beam here, since there is not much, span difference in the slab. Okay. So just for a moment, just have a brief look whether the STAAD Pro model looks in accordance to your the center line diagram which you prepared. So this is okay. This is good, and it is good to go. Now the thing is for you to select the columns, and we give it up to the foundation level. So for that, we go to select node cursor, and we select all the columns. You can have the reference. For having the reference, minimize both the files here. This for this you need to just minimize this, and here you need to view just all the columns, right? So a node cursor selected, select this node, selected, press Control and select all the other nodes which has the columns. We'll uh, use your translational repeat to provide these columns up to foundation level, and this and this and this and this, and actually all the four nodes here. Done. Now just maximize and use go to geometry, and then use the option of translational repeat in the y direction, and it will be your plinth height plus foundation depth. So I'm taking foundation depth 1.5 plus plinth height as 0.45. So total it is 1.95. So we'll take 1.95 here, and then default step spacing. First of all, like I need to change it in that. Okay, both are the same now, 1.95, and y direction, and it will actually be minus 1.95 because it is in the downward direction, right? Downward direction minus 1.95, and then click on OK. So once you click on OK, then go to View and isometric structure. Now keep this arrangement. Don't click anywhere else because we need this. This nodes will help us to connect the columns, right? Go to Geometry, click on Add Beams, and add the beams from here. So this was earlier my plinth level, and the bottom one is now my foundation level. So once this is done, just go to view and go to the front view, and after that select this any of this. You go to select beam cursor, and in using this beam cursor, select this particular option here. All the beams are selected. You can just go to view and have a look at this isometric views. You can see all the beams have been selected here. So go to geometry, and after going to geometry, uh, you can use the option of translational repeat, and in the y direction, the spacing by default, you can, I'll just note here what the spacing they have provided from the elevation. You can see it is a 3.2 meter, right? And 3.2 meter. So this spacing here, just y direction 3.2, just mention this, click on this, and then okay. So once this is done, we'll connect all the column to column nodes. So we'll go to geometry, add beam, and this is how you connect all the column to column nodes. Use the buttons in your screen, direction buttons, up arrow, down arrow to just move and need the model to a suitable position so that you can know where the portion you are connecting is the actual portion, right? So you have to be sure of that. And after that only you should join it. Two rows of columns I have joined. We join the corner ones. They are easy. Just not clicked on a node. That's why it was asking to add a node. So it's good that it asks to avoid any error. Okay, now the middle ones, they are a little bit tricky, just not tricky in the sense you have to just to connect it properly. Okay, this is this row. And there is another one. I think two at the center. So this will go here, you know that. This will go, this will go here. And let's see if any other column is remaining. So it is 1, 2, 3, 4 in the back, last row. So let's go from the front. So in the front row, we have 1, 2, 3, 4. So there is uh, 1, 2, 3, 4 in the front, and then 1, 2, 3, 4 in the second row, 4, 4, 8. So 1, 2, 3, 4 in the front row, 1, 2, 3, 4 in the second row, 4, 4, 8. And there is two, there are two here. And so there are two next. And then there is, and then there is after the two, there is another two column. Okay. There is this two, there is another two column. And after that, there are other two columns. You can see here. Uh, two, and then two, and then two, and then last four. So here like this, two, 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 and four. So we have done all the columns. So final check, you can just count all the columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Just open the CAD file. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we are good here. And like this, you have to check for every single project you make. And once you do that, just to go to the view, and we need the front view, and go to select and select the beam cursor. Select the top beam along with the columns, and then use the option, go to geometry, use the option of translation repeat, y direction, 3.2 meters we want to give, click on OK, and this building is ready here. Now go to this select node cursor, select all the nodes from the bottom, node tools, and then node tools assign supports, create supports, fix supports to denote the connection between your beam and column, and then just select all the nodes here, assign to selected nodes, assign, and yes. So once this is done, just close it. And after you just close it, go to view and go to this 3D view. So the building is modeling is almost done. Just then go to properties and we'll create some properties. First property we'll create for our first of all I'll go to view and sorry select and then turn on the beam cursor. Okay. So first property I'll create for my for our columns. So we'll just click on define and rectangle, and here we'll define the rectangle. This will be 300 into 300, 0.3 into 0.3. This will be it, and click on add and close it. So this will go to select and select in the case of beams. You can see in the case of beams, you select parallel to Y and assign yes. So now for the plane beam, this model we are checking. So we'll just see what they provide for plane beam and see whether the design is safe or not. So this is for the plane beam what they have provided. Let's see section of beam. It is okay. This is done. I want the plane beam details. Plane beam tie. Okay, so plane beam details they haven't column and section column and tie. I think this is the same. So it is actually 250 into 300, right? 250 to 300. So 250 into 300 they provide. Let's see whether it's passing or failing. So for plane beams, we'll just go to define rectangle 250 0.25 into 300 0.30 and click on add. And for the roof beams, let's see what they provided in the drawing. They provided 300 plus 120. It is actually 420, right? 420. So it is 250 into 420. And for the roof beams, it is 250 into 420. Right. This is a 250 into 420 thing. So, and then click on add, close, and this one we have to assign. So this for this plane beam, we'll go to view, select the front view, select all these beams, and then assign to selected beams, assign. And then for the next option, the roof beams, we'll select this option and this option, and then assign to selected beams, assign. So we are done here. So once we are done here, just see in the 3D view, and this is the structure which is done. So the next thing which you can do is you can insert the load of the slabs. So there are two ways which you can do it. Either we insert the load of the slab or insert the slab as a plate element in the STAAD Pro software. So we can do either of them. So in this particular video, we'll just use the load of the slab. We'll calculate the load of the slab and we'll insert it. So as you can see in this figure, the slab width is 120. So we'll take 125 mm because 120 is not really a size which uses. So 125 mm slab thickness. So we'll calculate the weight. So 0.125 into 25, it is 3.125. So 3.125 we'll use that for the slab loading. So let's do this. And for that, we'll need to go to your loading. And first of all, we'll define the seismic load, add the seismic load here. And this will be as per Indian 1893. Generate. This building is in zone 5 and special moment resisting frame. Always select this for RCC buildings. This is normal. This is what this and what factor is 1.2 and this is 1.5. So this is all other buildings and this is in medium soil and RC moment resisting frame, damping ratio 5%, and click on this generate. And when you click on this generate and click on add. So once this is added, just close this and you want to add some things here. So we'll do these things. So first of all, you want to add self weight factor 1. Seismic load, there is no negative, so that factor 1. Joint weights don't need, member weights we need UNI, and this is 3.2 meters. We'll just calculate for 3.2 meters. In 3.2 meters, some portion is beams or only. So we have beams and all. For beams, if you just see the diagram. So for beams, 300 will already be deducted from the 3.2 meters, which you are having from the floor to floor height. So simply just 3.2 minus 0.3, it is 2.9. So we'll calculate the load here. So 20 into 2.9 into these are 125 mm walls. So 0.125, it is 7.25. So 7.25 we'll use for the whole wall, and in some portions of the parapet wall we'll use a little bit less. Let's use 3 for the parapet wall, 7.25 for this. So UNI 7.25 kilonewton meter. Add this and also add 3 for the parapet wall. Add this and element weights, pressure, this floor weights. You can just add this floor weight. So as a floor weight, we had calculated 3.125, 3.125, and the range, Y range you have to give. So the building has 2 floor places where you will have the floors here. One is at 3.2, another is at 6.4. So we'll give the range between 3 to 6.5. Okay. The Y range minimum 3 and maximum 6.5. Click on add and then close. We'll define this later. So and then load case details, click on add. First load obviously will be the seismic load. So it will be SLX, seismic load in X direction. Click on add. And then this will be the seismic load in Z direction or Z direction. Click on add. Then it will be obviously without it, anything is not possible. Dead load. Click on add. And then the live load. And this will be LL. Click on add. And then just close this. Seismic load, just click on add. Here we have this seismic load here. So seismic load, we factor in the X direction and factor is 1. Click on add. And seismic load in Z direction, click on add. And this will be seismic load, Z direction 1. Click on add, close. Dead load, click on add. Here we have the self weight, and the self weight is, since this is not a seismic load, it will have direction and it will be from top to bottom, so it will be -1. Click on add, and then we'll have the floor load. Floor load, first of all, let me add the load of the slab, minus 3.125, and the range will be the same, that is 3 to 6.5, right? And then click on add. And then we'll add the live load, your floor finish load here. So floor finish load will be 0.5. So it will be minus 0.5. The ranges will be the same. This is for the floor finish. Tiles, marble, whatever you do the floor finish, everything will be covered in this 0.5 meter as per IAS 875 part 1, the code for the dead load. Click on add. And then you'll need the member loads. So member loads here, minus 7 point, what was the thing? 7.25 minus 7.25, and click on add, and then another for the parapet wall, -3, click on add. This is done, and then we'll have the live load. Live load only will add one load here. Just add the floor load. This will be for the residential building as price 875 part 2. It is 2 kilonewton per meter square. Since it's acting top to bottom, so the negative direction. And here, same the range 3 to 6.5. Click on add. Close it. So live load is defined as usual. And I also define this loads. So first of all, we'll go to the view. Okay, we have to define more loads, some more loads. Okay, so these are defined in the seismic zone. This floor weight is defined, but we have to take a portion of the live load as per the IS code. So as per the IS code, if live load is 2 or less than 2, so then you have to take 25%. 25% of 2 is 0.25 into 2 is 0.5. So 0.5 of load we have to take. So either we can take it or we can just add it here. I'll just add it here. This plus 0.5, it will be 3.625, right? I'll just add it here. No need to change it again, right? So this is done. And first of all, let me assign. Okay, another member in the member weight also, we have to add the floor finish load. I haven't added that. So it will be in the floor weight and it will be the floor finish load. I'll add this floor weights, and this will be minus 0.5, and the minimum range is always 3 to 6.5. Click on add. So finished load added, live load, factor taken, and also the slab load taken. So this we are good in this. And first of all, for all the this is for all the walls. So we'll go to front view. Okay, we can select all the walls one by one. It doesn't make much difference. We'll just put the loads in all the walls here, which are having. So this is the case. Assigned to selected beams, assigned, and yes. So this is done, and this 3 will do it later. 7.25 again, just assign to selected beams, assign, and yes. And then the self weight will be only, obviously this is already assigned. This will be assigned to view, assign, and yes. Self weight has been assigned, and then the parapet wall load. So this we want to do. So just select this and right click, and then new view, whatever comes, just click on OK. Go to the top view, and when you go to the top view, you can see the portion here. See the plan first, and see the portion where you have the staircase in the plan which you've downloaded. On this portion you have staircase. Apart from this portion, that is from the bottom, the second row, everywhere will have parapet walls. So parapet walls will go from here. I'm pressing control, by the way, and pressing control and help me to select. Sometimes it messes up, but it helps to select. And then this, there we go. So this will be for 3, right? Assign to selected beams, assign, and yes. Again, this will be this I need to select again, obviously. Select this, select this, select this, and select this. Assign to selected beams, assign, and done. Now this 7, I need to assign it again. This portion, this portion, this portion, and this portion. This is the staircase portion. Assign to selected beams, assign, and yes. And same as for this, this one actually. Assign to selected beams, assign, and yes. So this is done. All the loads have been defined, and probably we haven't done any mistake. So after doing this, we just go to design, and in the design, select the concrete from here. And after that, just select the IS code, IS 456. Select parameters first. You can select a lot of parameters, but there are some parameters which you need to select to just make the model design good. Clear cover, reinforcement grade, maximum and minimum size of reinforcement, minimum size and maximum size of reinforcement. And I think we're done. Let me see 1, 2, 3, 4, 5, 6, 7. Anything else? FY main, FY secondary, maximum main, maximum secondary, minimum main, minimum secondary, clear cover. And I think we have missed the concrete grade, right? Concrete gate, FCK. We need to take, yeah, this one. These things, these are the minimum things that you need to take. Just click on OK. Define parameters. Clear cover, 30 mm for beam. Let's take a good here. And 40 for columns. Add. Don't know whether it's added or not. Check. If this is 2 times, then I'll delete. Click on add. FCK is M25 will take. So it is 25, 1, 2, 3. And then click on add. FY main, FY 550 we are using. 550, 1, 2, 3. Click on add. FY secondary, 550. 1, 2, 3. Click on add. Maximum main, 25 mm. Okay, let's go 20. And this is only G plus 2. I mean, maximum secondary, 10 mm. Minimum main, 12 mm. Minimum secondary, 8 mm. And then close. So let's see if I added that thing twice. Clear cover, yes, I added twice. So delete command, one of them deletes, is deleted. Commands, design beam. Add, design column, add, take off, we'll give the concrete quantity, and close it. So we'll have this thing, clear cover. We'll have to give, just go to view, display whole structure, and the clear cover for this for all the beams. So go to select and parallel to X, parallel to Z, and then simply assign to selected beams. Clear cover, this one will be select parallel to Y, assigned to selected beams, assigned NDS, and this will be assigned to view. Reinforcement is everywhere. So obviously this is assigned to view. Design beam, parallel to X, parallel to Z. Design column, parallel to Y. So once this is done, this thing is done. Just go to analysis and design, and obviously concrete IS 456. This is done here, right? And go to analysis, and after that concrete, and go to analysis, and you have to just add analysis if you need to. So analysis commands, go to analysis commands, and then click here, no print, and click on add. Perform analysis, you need to add it. Okay. So just close this. If you want, you can also, tick on the other things if you want. So no problem in that. So after that, you can just click on this run analysis. If your structure is good and well designed, there will be no error. Otherwise, you'll see the error. Thing is, if you have an error, then you'll see in the starting. So there are no errors here. So we can go ahead and view the output file, but we are done here. We can see the design here, concrete design. You can see 4 bars of 16 mm and the beams. Let's check a plain beam. Here we have 3 of 12 for the top, 3 of 12 at the bottom. So good. Let's take a roof beam. So we are having here 3 of 12 at the top and 3 of 12 at the bottom. So we're good in all the designs here. So right now just press Ctrl+S and save the file. So once you save the file in the STAAD Pro, just and save it and then close it. So file has been saved. Now we want to take out the drawings. So to take out the drawings, we open the RCDC. So I have already made separate videos on all the settings and all the RCT. So this will be a little bit quicker, but also even though we'll get it. Only the to the point explanation I'll give. There is nothing, rocket science in this. Very easy, and just need to apply common sense. One, and open the stat file, obviously, and will be in desktop. This is this one, and this one is the stat file opened. And first of all, we want to design our footing. Let's create new project. We'll design footing, and then we'll design beams, the columns. That's all, right? So these are the you know columns here. So I have changed my mind. I first want to design the columns first. Why the columns? Because some I might change some of the results, and this might affect the footing design. So that's why I want to design the column first. So always it's better to design the column first. And if there is any changes required, I don't think there will be any changes, but still it's better. So I'll just close this. I don't want to save anything, right? Uh, First of all, I'll open again RCDC. We'll design the columns. Yeah, and it is opened, except one, and then stat file, location, column and wall, create new project, data imported. It's very easy, very easy. Don't see that it's not easy and all. Very easy, nothing you need to do. So first of all, go to file, go to settings, go to design settings. And here you can see all these design settings are there. If you want ductile design, just click on this ductile design and no problem at all. And then you go to set reinforcement it settings. In the reinforcement settings, you can choose the minimum and maximum bar here. Suppose I'm going with 20 here, and this links also 8. The die of bars which you want, and then click on OK. So in this detailing and reinforcement stair settings, rebar size, mid rebar size, everything you can see. And then the zone settings also you can see here. And here you have this in the settings, you have this basic load cases, and just define the load cases here. This is earthquake X, this is earthquake Z, this is your dead load, and this is your live load. Just select all these loads first using control and then click on OK. This is a regular structure. So add from template for regular structure, click on OK. So load cases have been added, and you can now, design. So for designing, just simply you can go to this design and click on auto design. Let's just have a shortcut here also. Just click on auto design. The design will be done in some time. You can see the design. If anything is failing, that will become in red, or you can see how detailed design this is given. So now the only thing is to just get the output here. So text schedule, ductile schedule. Let's see here. So this one, you can see these are the groups. First of all, I'll save this file, RCDC file, Control plus S. It will be column design RCDC, right? This will be the file, and then we will save the cat file. So it will be column schedule. Then after the column schedule, we want this detailed drawing for all columns. So these files, the except files, this will open in AutoCAD. You can see all the drawings here. Very detailed along the tie details, everything is given. So there is no problem whatsoever, right? So now we'll go to save this file. This will be column schedule 2, right? And and then report. Then will be your elevation also. You can just check out for all the columns. You can see here the detailed elevation for all the columns along with the lapping links. So very in very detail you'll find everything. So this will be the column elevation. Next we have this. So you can also import the project setting if you anyone wants the what are the settings you have done. You can also import the project settings here. So then is the design component combination, and in this design combinations, you can sorry design calculations. Design calculations required when it is you submit it for vetting. Then they ask for what is the design calculations you want to check. So that you can save Control plus P. Don't press Control plus S. Just press Control plus P and select Microsoft Print to PDF. And then you will have this file location. So this name is design calculations column, and then this is saved. And after that, you have this, bill of quantity. It's a very interesting feature. I see BOQ summary. Just click on this M25 grade and grade of steel. You can just change here. By default it has taken FE415, but there is also option of changing. We'll see that later. Land area, let's give 30,000 per square meter, right? And this rate, let's give along with labor 102 rupees per kg. And this is shuttering, let's give 800 along with labor, and then click on OK. We have this bill of quantities. We have the total quantity of concrete, total quantity of steel, and you have this thing. FE415 we can change to FE550. That is, but it will be a little bit less reinforcement. Okay, but the rate will also be the same, quantity almost the same. Okay, press Control plus P here and print here, and then it will be this will be your column view. It's very useful. And then rebar and rebar settings, you can generate the rebar. So for generating the BBS, go to BBS here and generate BBS. For all the columns, we want the BBS, and just click on generate. No need to do anything else. And it will take some time and generate the BBS, which you can save as a CAD. So you see, we have the BBS here, all the detailed, BBS we are having here. You can see here. Okay. So save this file, not waste too much time. So this is the column BPS, right? So this also you can just save here. This is the column layout. So just save this column layout. So everything we need is saved here. And then we'll just save this file, save this project, and then close it. For new project for the beam design, lastly we'll do the foundation. Same file, beam. So whatever the levels where beams are there, 3.2 and 6.4, create new project. So first of all, go to settings, general and rebar settings. Here, just change the grade of steel to FE550. And then main steel rebar will always be 12, and maximum we can just do 20. for this because this is on G+1 building. Otherwise, you can just increase shear steel rebar. This is okay. And SFR is also side face reinforcement, not required in this case. For deep beams, it is required, but it is 10 is better than 8. So, okay. And then go to settings, rebar curtailment. You can just change this settings for the extra bar and all. And preferred bars, basic load cases, simply go to there. Earthquake load X, earthquake load Z, dead load. Control and select all this and okay. Add from template, regular structure. Okay. And then go to design, auto design. So all members are passing and you can see the reinforcement is also pretty good. So like this, you can import all the things here from this reports here. So first of all, I'll go and text schedule. I'll just do, click on OK and save this. Before saving this, I have to save the RCDC file. So it is beam design. Beam design RCDC, and then I can save. Now, after this has been saved, then I can save this CAD file. Beam schedule. Reports elevation section for all beams. For section I want. So you have the elevation and section of the beams here, detailed elevation and section. Just save this. And then in the reports, you have this design summary and design calculation. We want the design calculation. Okay. Control P. Saved as PDF. Then bill of quantity, same thing we can do. BBS, generate the BBS for all the beams. Save the file. So this is done on the design for beams. Save the file here. And if you want the design layout as well, this is the design layout. Save this file as well. So it is the beam layout. And you are done. The beam design. Ctrl plus S. Save all the changes. Close it. Last but not the least, we need the footing design. File location, footing design, load cases imported, file, and we'll select the column, import column. That's why we have designed the column first. Import column data, all the columns which are created, this will be changed in RCDC, this will be imported. Column size and column mark has been imported. Then simply go to reinforcement settings. You can change the reinforcement settings from here. And you can also change the general settings. This 8550 will do. And then cover 75 mm for footing. And others is by default. As we see, you can do here as we will do. Let's give 175 as we see, and then click on OK. And then you go to this basic load cases. Define them as earthquake X, earthquake Z. This will be our dead load, This will be a live load. Select all these loads, take them. Okay. Add from template for regular structure. Okay. And sizing combination. These are the unfactored load combination. This also you go for a regular structure. You don't have to add any unfactored load combination. This is one advantage of this design using RCDC. Okay. And then when you have done it all, just you can select this auto design. Footings have been designed, no footings are overlapping, and since sizes are pretty much proper. So first of all, I'll just save the layout here. Then the schedule have to be saved. Vertical is better, right? Horizontal, vertical is better. Save this. First of all, I have to save the file. I always forget. So it is the footing um, design RCDC. So you simply save the file, and this will be footing schedule. Save, and the reports detailed drawing of the footings, or in all the footings detailed drawing may plan also we want. And section, okay, section L and section B. Let's take the sections in mark section in plan. We mark sections in plan we don't want. Okay, just click on OK. Let's see how the drawing comes. We can later change how this comes. No, this is okay. This is good actually. This is good. Detailed sections are there for the footings, and if we just change it a little bit, reports detailed drawings, all the footings, section L and section B, and then okay, then what happens? Then you can see, you have these sections as well for all the footings. This is good, right? And plan settings, you have everything you got. Just save this file. Footing layout and sections. What else do you need? You don't need anything. Just the design calculation for all the footing. Okay, and you have this Control plus P. Microsoft print to PDF print. So design calculations, footings. Save, and then you can generate the BOQ. This is the same process, and then you can generate a BBS for all footings. Obviously, you want generate. We'll see the BBS here for all the footings, very detailed. Save the file, and here will be footing BBS. So this you have done. See, I have provided a lot of effort in making this. Just to make sure you like, share, and most of all, learn. Thank you. Bye-bye.